You know, when we look out at a towering mountain peak, it feels completely eternal, right? I mean, it looks like it's been there forever and will be there until the absolute end of time. But as we'll see in today's explainer, our human eyes can be incredibly deceiving. These massive, imposing structures aren't static monuments at all. They are actually dynamic evidence of an incredibly restless Earth, a planet that's constantly changing, shifting, and sculpting its own surface over millions and millions of years.
So that brings us to the big central question we're exploring today. Are all mountains created the exact same way? It's really easy to just assume a mountain is, well, a giant pile of rock pushed up from the ground in some uniform, standard process. But shattering that illusion of permanence reveals a much more mysterious, ongoing geological drama. It turns out the Earth actually has a few very distinct architectural styles.
Okay, let's dive into this. Here is our trail map for today. We'll start with mountains, Earth's moving canvas. Then we're going to break down the 4 specific building techniques: fold mountains, block mountains, volcanic mountains, and residual mountains. Finally, we'll wrap up by decoding Earth's deep history.
All right, Section 1, Mountains, Earth's moving canvas. Let's quickly define what exactly makes these giants before we look at how they're built.
So, what actually is a mountain? Well, it isn't just any large hill. It's a massive natural elevation forged by geological forces operating over deep, deep time. We're talking millions of years here. This isn't an overnight process. And these towering giants absolutely run the show. They dictate our weather patterns. They act as the source of our major river systems, and they provide vast habitats. They are literally the backbone of the continents, shaped entirely by the immense power of time and pressure.
Moving right along to the first mass-building technique Earth uses. Section 2, Fold Mountains, Epic Rock Collisions.
Let's move to the mechanics and see exactly how this builds. Picture this: 2 massive tectonic plates just slowly, unstoppably marching toward each other. Over millions of years, the sedimentary rock layers sandwiched right between them undergo unimaginable compression. Eventually, the solid rock physically buckles. It folds into these giant wave-like shapes known as anticlines and synclines, relentlessly thrusting miles into the sky. It's literally the crust of the Earth wrinkling, kind of like a rug being pushed against a wall. And because of these massive continental collisions, fold mountains share some really distinct characteristics. We're talking about incredibly long, continuous mountain chains boasting the highest elevations on the entire planet. They've got those classic sharp peaks and plunging, deep valleys. You'll always find them right at convergent plate boundaries. That's where the geological action is happening. Just think of the Himalayas, the Andes, the Alps, or the Rocky Mountains. These are absolutely the highest and most extensive mountain ranges on Earth.
But you know, Earth doesn't just smash things together. Sometimes it rips them apart. That brings us to Section 3, Block Mountains, the Deep Cracks.
Now, this is a completely different architectural style. Instead of squeezing together, imagine things pulling apart. Immense tensional forces stretch the Earth's crust over deep time until it physically cracks, developing huge faults. The landscape then completely transforms as the crust breaks into gigantic, solid blocks that move vertically along these fault lines. Some blocks are thrust straight up into the air, forming what geologists call a horst, while the blocks right next to them sink down to form a valley, or a graben. Those uplifted blocks, those become our towering block mountains.
Because these are essentially giant, unbroken blocks of rock shoved into the sky, their visual profile is super unique. They typically feature incredibly steep fault scarps, which are basically giant, sheer cliff faces on one side, and remarkably flat or gently sloping tops on the other. You'll find them wherever there's significant faulting and rifting going on in the crust. And a fantastic side effect, they are notoriously rich in mineral resources. Famous examples of this sort of geological cracking include the Vosges Mountains in France, the Black Forest in Germany, and the magnificent Sierra Nevada. So, we've covered crashing plates and cracking crust. Now let's look at the third and easily the most explosive building technique in Section 4, Volcanic Mountains.
Now, this process is wild. It literally builds a mountain from the inside out. Deep underground, intense heat and pressure cause magma to violently breach the crust. Once it hits the surface, we call it lava. As this lava, along with massive amounts of ash and volcanic debris, cools in the open air, it solidifies. And when this repeats over thousands and thousands of eruptions, these layers continuously accumulate. They just stack higher and higher to physically form a towering mountain around the vent.
You can almost always spot one of these instantly. They've got that classic, highly symmetrical cone-shaped appearance and the presence of a crater right at the summit. They are constructed entirely of layered lava and volcanic materials, and depending on what's going on underneath, they can be active, dormant, or completely extinct. Mount Fuji, Mount Kilimanjaro, Mount St. Helens, and Mauna Loa are all magnificent examples of Earth's fiery engineering. And hey, we shouldn't forget, these fiery builders are vital. They gift us incredibly fertile volcanic soils and vast amounts of geothermal energy.
Now, what's really interesting about this slide is the dramatic contrast at play here. Up to this exact point, we've talked about fold, block, and volcanic mountains. And what do they have in common? They are all pushed up by Earth's powerful, deep internal forces. They are the builders. But Earth is also a restless, relentless eraser. And that brings us to our fourth mountain type, residual mountains, which are completely carved down by Earth's external forces.
Which brings us to Section 5, Residual Mountains, the Great Eraser. These are landforms sculpted almost exclusively by the incredible power of deep time.
So here's exactly how this geological eraser works. Imagine an existing landscape just taking a beating from the elements. Over millions of years, the slow but truly unstoppable power of wind, water, and grinding glaciers continuously strips away the softer rocks. It's essentially sanding down the surface of the planet until only the hardest, absolute, most resistant rock masses are left standing tall, as mountains, long after the surrounding material has just washed away.
When you look at residual mountains, you are literally staring deep into geological time. These are ancient mountain systems characterized by very rounded, heavily worn-down peaks. All the sharp, jagged edges of their youth have been entirely erased by millions of years of rain and wind. These mountains, like the beautiful Aravalli Range, the Catskill Mountains, or the stunning Scottish Highlands, they serve as vital tools for scientific research. They physically reveal our planet's deep history by exposing ancient rock layers that were once buried miles and miles underground.
All right, let's bring it all together. Section 6, Decoding Earth's Deep History. Let's look at the grand summary of how all four of these massive competing forces interact to shape our world.
And this brilliantly illustrates the whole picture. Consider this your ultimate cheat sheet to Earth's restless architecture. We've got fold mountains born from violent compression, block mountains from the cracking and massive vertical uplift of the crust, volcanic mountains from the fiery, explosive accumulation of lava, and residual mountains from the prolonged, relentless erasure of weathering and erosion. It is just an amazing, endless cycle of building up and tearing down over millions of years.
So the crucial point I want you to take away from this explainer is this. Mountains are the literal history of our planet, written directly into the landscape. They aren't just pretty static scenery for a postcard. These epic geological processes dictate global climate, they give birth to the freshwater rivers we drink from, and their slow erosion creates the fertile soils that sustain literally all life on Earth. We are completely reliant on the continuous movement of this giant canvas.
So, let me leave you with this final thought to wrap things up. The next time you look up at a towering mountain summit, are you just going to see a static piece of rock? Or will you see a dramatic, violent, and incredibly beautiful chapter in Earth's ongoing geological story? Thank you so much for exploring this with me today, and definitely keep looking closely at the forces shaping the world around you.